Hello, I'm Renzo, your AVP for IT Skills Training, and today we'll be having a Python workshop. So last time I had a Git workshop, and that was more on version control. So this one, it's more on learning an actual programming language. And what is Python? It's a general purpose kind of programming language. You can use it for data science. You can use it for web development like Django or Flask. You can use it for data visualization. So Python has a lot of libraries you can use. So today though, we'll just be discussing more on the basics. So for those taking introduction to programming, this might be able to help you at least with regards to learning the basics. So what do we need to do first to get started? First we want to go to Anaconda. So we'll be using Anaconda Navigator to install Jupyter Notebook. So for here, just get started. And then you just want to install the individual edition. And then once you have this, you just press download and it will install basically everything for you. And then once you have Anaconda Navigator, it should look something like this. And then you just want to install Jupyter Notebook, which is here. It should say install there or something. And then just launch it whenever you can already. So I'll just launch it. And there's a lot of command line stuff here, just don't mind it. And there you go. So we want to make a new file. So how are we going to do that? I'll just pick a directory. So for example, I want to place it on my desktop. Then you can just press new. Python 3. And there you go. You have your notebook. You can type anything there. So we're just going to name our notebook Python Workshop 2020. Yes. Okay, so what will we do now to get started? So I just want you guys to print your first Hello World program. So to print in Python, we just use print. And then we put anything here. For example, here, we're going to put double quotations. That's going to imply that we're going to put a word or a string. So for here, we're going to put hello world. And then to execute, you just press Shift Enter or Shift Return if you're in Mac. There you go. Or you can choose to press the run button. So there you go. We have our first hello world program. Now, how do we make comments in Python? So what are comments? Comments are basically pieces of code that you don't want your program to run. So they're basically just like side notes or like comments on what your code is all about. So for example, for here, to make a comment, we're going to use hashtag. Then we're going to put this is a hello world program. So this will just tell the user, okay, this program, what it does is it prints hello world. So behind the scenes, the browser doesn't really care about this chunk of code because you're telling it that it's just a comment, like it's not meant to be run by the IDE basically. So now we're gonna talk about math operators. So for here, we're gonna put math operators. Oops. So what are the different math operators you can do in Python? You can do addition, so print 2 plus 2. We can also do subtraction, so we can print 5 minus 3. We can also do multiplication, so 10 times 10. Oops. Then we can also do division, so 20 divided by 4. So these are like the basic operators you already know, like in your typical like basic math classes. Then there are also like other operators that are pretty weird syntactically in Python, which are, for example, if you want your division to only produce like an integer and with no decimal. So for example, if I print 10 divided by but with double slashes 3. So you would expect it to be like some big decimal. But for this case, if it's double slash, it's only going to give off an integer. Then you can also do modulo. So what modulo does is it prints the remainder of the result. So for example, 10 modulo 3. If you do 10 divided by 3, it's 3 remainder 1. So the result of this will be 1. Then you also do exponents. So to do exponents, you do double asterisk. So for example, if you want to do 2 raised to 3, you do double asterisk. And if you want to prove all of the answers that I just told you, you can just print this. For example, 2 plus 2, the answer is 4. 5 minus 3, 2. 10 times 10, 100. 20 divided by 4, 5.0. So here's what you notice. If you use 1 slash, it's always going to print a float. So 20 divided by 4, it's going to print 5.0. But if you do double slash, for example here, 10 divided by 3, but with double slashes, so you're going to think it's going to give like 3.67, whatever. But in this case, it's only going to print the integer version. So if we do like a whole number, 9 divided by 3, it's still going to print 3. It's not going to print 3.0. Then if you do 10 modulo 3, as we said earlier, it's a remainder. It's going to give off a remainder. So 10 modulo 3 is like 10 divided by 3. So the answer is 3, but its remainder 1. So the answer is 1. It's going to give off the remainder. Then 2 raised to 3, so double asterisk, that is going to give off 8 because 2 raised to 3 is 8. So those are the basic math operators. Pretty much all the math operators you can do in Python. And as you know, it also follows PEMDAS. So the typical math stuff you know in your head right now. So for example, if we do 5 plus 3 times 2, it doesn't go linear. It's going to compute in the typical PEMDAS manner. So for example, 3 times 2, which is 6 plus 5 is 11. So as you can see, it's 11 as the result of that expression. So what are the different data types you can do in Python? So data types. So first of all, there's integers. So these correspond to like numbers with no decimal points, or basically whole numbers. So as you already know in math class, integers are just basically what I said. So 12, 10, 9, 8, 9, whatever. Floats, on the other hand, are, so floats, are basically decimal points. So for example, pi 3.14, 19.20. Even if you put dot 0, like 18.0, even if you might think that it's a whole number because it's 0.0, so you're basically implying 18. But Python still sees it as a float. So always keep that in mind. As long as there's a decimal point, it's a floating point number. You can also do like negative numbers, so negative 1.25. Also in integers, if you do like negative 10, that's also an integer. Next, we have strings. So for strings, they're basically like, what do you call this? They're basically like an array of characters. So a sequence of characters. This implies you can make words in Python. So for example, in this case, we're going to use double quotations or single quotations. It's up to you. So you can do Renzo. You can also do single quotations like this, Renzo. You can also have spaces. So for example, have a nice day. This is a Python program. One thing to keep in mind also is that if you put a number in a string, for example, if you put in double quotations, Python sees it as a string. Gets? So, for example, for integers, if we do type 12, it's going to give int, meaning it's an integer. But for floats, if we do type 3.14, it's a float. Now for strings, if we do type Renzo, it's a string, str. So for example, if we do like 3 here, it's still going to see it as a string. Gets? Now, how do you convert, like for example, if you want to convert like an integer to a float? That's easy. Python has like built-in functions for that. So for example, I have an integer 12 and I want to convert it into a float. So first we do float and then just put the integer you want, 12. 12.0. If you want to convert a float into an integer, for example 3.14, just put int there, 3. Now, if you want to convert a string into an int, that's also possible. Int 3 as a string, it's gonna print 3. So if we do type here, like type, what type of data is this? Whoops. There you go. It's an integer. Now we have that out of the way. We now know the different data types you can use in Python. Well, these are not all the data types, but these are basically like the most basic types of data that you're gonna discover once you're starting out with Python. Now for strings. Strings, yes. Now, for strings, they actually have like a lot of Pythonic ways where you can manipulate them. So for example, if I have like yes as a string, if I multiply it by, for example, like 10, if you go to other programming languages, this wouldn't work. This would actually give an error because you can't really multiply words with integers or like floats. But in this case, in Python, the Pythonic result to like yes times 10, it's gonna print yes, 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 yes 10 times. So if you wanna like repeat strings repetitively, like for example 10 times, you can multiply strings by numbers. Now, let's comment this for now. If you want to like combine strings, for example, I have a first name input and a last name input, and you want to combine those. How are we gonna do that? So what we do is let's print this. Actually, it's not printed for now. So for example, we have a first name Renzo. Then we put a plus. That means that we're gonna like concatenate two strings together. So tan. And what this gives out is Renzo tan. But if you notice, there's no space. For that, you need to manually add it. There you go. Renzo tan. Now, for example, there are like times where this can get very hectic. Like if we print this for now, then we can put like plus like a middle name, John. Like for example, your name has like a lot of names. So we have to put a space there. Then we can put a middle name like go plus space again. So this can get really hectic. Like if we print that, it works. But this can get really hectic at some point. So what Python 3 added a new feature which is called the f string. Here you go. So instead of putting spaces, you can just put a manual space. Like you can just press space. Literally press space only. So for example here, Renzo, John, Go, Tan. Same thing, it works. So you can see the power of f strings there. If you ever want to like add, like format it in a way that it's human readable, you can use that. Now, what if we want to store our values inside of like a variable? For example, in math, you know about variables. So for you to do that, let's put variables here. Variables. For you to store variables, you just equate it to, let's say a character, for example, x equals 4, or name equals Renzo. So what it does is behind the scenes in memory, it's gonna like space out, like as for example, think of memory as like a grid. And then what it does is it's gonna reserve one piece, like one square of memory, and put Renzo in there. Then name that part of memory name. So whenever you like reference name again, it knows that you're referring to Renzo. So for example, first underscore name is Renzo. Last underscore name is Tan. Wait, sorry. Now, for example, if we print first name, you see, it prints Renzo. If we print first name plus space plus last name, it gives Renzo Tan. So, same banana. You don't always have to manually place the strings. Instead, you can store your strings inside variables so that you can repetitively like reference them in multiple parts of your program. So in this case, we can also implement an f string, but note this will be a bit different compared to like doing first, like, okay, let's compare it. First name plus last name. And there. So as you can see, it's if you just put first name and last name, Python will see it as a string itself. It won't see it as a variable. So how are we gonna make it a variable? All you do is put curly braces here between last name and first name, and you don't need to add the space anymore. So it's just f. You're saying that the string is an f string, a format string. First name, last name. Compared to this, it will print the same result. So you're not really forced to choose whatever you want. Well, I mean, you're not forced to choose one over the other, but whatever you want to use, what's more comfortable for you, then just stick with that. But for me personally, I like using the F string since it's more versatile with like, it's cleaner basically, and it's more human readable in a sense. Now that we know how to store variables, we know how to use strings. Now, what are the types of like methods you can use in strings? So let's stick to the next one. So string methods. So for example, we have like John, and we store it in a variable. How do we measure how many characters are there in John? For example, in here, we can calculate the length. We use the length property using len. So we can just put John here, and then we just print it. There you go. It says here, John has 4. Now, what if we want to access a letter or a character inside John? For that, you get the variable first. Okay, let's do it without the variable first. So for example, you have John here, and then you want to access the O. So think of like this as a sequence. J starts with 0, O is 1, H is 2, N is 3. Now, if you want to access O, remember, index starts with 0 for J, starts with 0, 1, 2, 3. If you want to access O, we use 2. Now, if we print this, oops, O is 1. So, sorry about that, O is 1. So, if you print that, it's going to give off O. Now, an easier way to do this, since we already referenced John in X, we can just put X here. There, same banana. Now, if you want to look for more string methods, you can just search string methods. Because in programming, you don't really like memorize everything. Most of the time when beginners like start programming, they always think that they have to memorize everything, and that like if you don't like remember something, then you're a bad programmer. But most of the time, like even myself, I've been programming for 2 years already. I still search how to do string methods. So for example here, we also have capitalize. Converts the first character to an uppercase. So let's try that. Let's remove the prints. So we can do x dot capitalize. Oops, did I spell it right? Capitalize. Okay. Then let's print it. Oops, let's put this in lowercase. There. As you can see, John is in lowercase, but if we put capitalize, it's going to convert the first letter to uppercase. We can also do dot upper. So what upper does is it converts the whole string into uppercase. There you go. And dot lower, which is to convert the string to lowercase. So for you guys to remember, I'll just like capitalize upper. Then we can also put len of x. So what else do we have here that's important? So we have index also. So index print x dot index of, for example, we want to look for the index of h. Whoops. It has to be in string format. There. The index of h is 2. 0, 1, 2. And what's neat about this, if for example you don't know the index, you can use x.index. And for example, you want to print h again, you can just do x bracket this. Because this will give off 2. And the x, in x, the second index, for example here, it results to 2. So x with the index of 2 results to h. So let's print this. H. So there you go. Now you know some string methods you can use. So what will we discuss next? Let's see. Now let's discuss more on the control flow of Python. Excuse me. Okay, so let's put here comment flow control. So there's a few operators you need to know. Double equals. There's double equals. There is not equal to. There's less than, greater than, less than or equal to, and greater than equal and equal to. Okay, so now that we know that what we can use for control flow, how are we going to implement control flow? Using these comparison operators. Before we get into like the specifics on control flow, we want to know how to use these comparison operators. So, for example, the double equals, it will result to true or false. So double equals means that these two values are equal. So for example, if I do 42 equals 42, it results to true. And what true is or false is, they are called booleans. That is a data type we forgot to discuss. Booleans. So these can be true or false. That's also a data type in Python. So 42 equals 42 is true. What is the difference with one equal sign and double equal sign? In equal sign, you're saying that you're storing it inside a variable. So for example, if x equals 5, x equals 4, you're storing 4 equal inside x. But if you're saying, for example, x is 42, and you're checking, is x 42? Here, you're saying, I want to store 42 inside x. Here, you're saying, is x, is the value of x 42? Now you know the difference of one equals and double equals. This is more for storing variables. This is more for checking equality. Now, what if you want to ask Python, are they not equal? So let's comment this out also. Let's comment this out. So for example, is 42 not equal to 42? False, because they are equal, obviously. If we put like 10, obviously they are not equal. So it results to true. Now, this is for checking inequality. Yes. Now, excuse me. Now these operators over here, they're more for numbers, like floats or integers. So for example, you already know this in math class. So is 4 greater than 2? True. Is it less than 2? False. Is it greater or equal to? Greater or equal to refers to, is it equal or greater? So for example, if I put 4 here, it's still true. If I put 2, it's still true. But if I put something greater, it's false. Now if you do the opposite way, it's the same thing. So this results to false because 4 is not less than or equal to 2. But if you put 4 here, it's true. Now if you put something greater, it will result true. Now, one thing to note also is that, for example, if we do like 42 equals 42.0, what do you think will that produce? Well, this will produce true. Why? Because Python sees integers and floats. If they are the same value, it will see it as true. And of course, if we do not equal to, it will result to false. Now, second question, 42, will it equate to 42 in a string format? The answer is false. It will not produce, if Python does not see strings equating to integers or floats anytime around, no matter what. Unlike JavaScript, like for example in JavaScript, they have type coercion. It will see it as equal. But in the case of Python, it won't see it as equal. Okay? Okay, so now that you know how to use comparison operators, we'll now use Boolean operators. So, Boolean operators. So this includes and or. So for example, if we do true and true, this will produce true. But if we do true and false, this will produce false. What does this mean? For the AND operator, if for example you have two conditions, one results to true and another results to true, it will produce true. But if any of these conditions are false, then it will always produce false. So in the AND operator, both conditions or two or more conditions, depending on how much conditions you're using, everything has to be true for it to result to true. So for example, if I put false here, I put true here, it will still produce false. Now, let's comment this, comment this. Now, if we do OR, in the other hand, for OR, at least one value has to be true for it to be true. See? True. But if you put N, it's false. Because both values have to be true for it to produce true. But if you put OR, at least one value has to be true for it to be true. If you put false or false, it will produce false. Get? So for AND, everything has to be true. But for OR, at least one item has to be true for it to succeed in becoming true. I know that might be a bit confusing, but just remember that AND, everything is true for it to be true. For OR, at least one condition has to be true for it to be true. Get? So for example, if you put it in real life terms, in real programs, 4 less than 5 and 5 is greater than 4. What will this produce? This is true because 5 is greater than 4. Because 5 is greater than 4, it will produce true. Now, if one of them is false, for example, if I put 4 is greater than 5, it will produce false because 4 less than 5 is true, but this one is false, so it will produce false. Now that you know that one of the conditions is true, if you put OR here, obviously it will produce true because one of the conditions is true, so it will produce true. Now that you know how to use Boolean operators and what results you can produce with them, we can now use if statements. Now, for example, if 5 is greater than 4, print this is correct. In this case, an if statement, what it has the if statement itself, a condition, then unlike in other programming languages, you use this, like semicolon, comma, I forgot what you call those. But yeah, you use that, and then you print, you do any like code you want to produce in the program, like what code you want the program to run, basically. So it says here, if 5 is greater than 4, print this is correct. It will print this is correct because this results In behind the scenes, this will produce true. Then if true, print this is correct. So since it's true, it will print this is correct. So in behind the scenes, it's gonna like make the condition like produce true or false. If it's false, then it won't run. For example, if I do 3 is greater than 5, it won't do anything because behind the scenes, this will put false. If false, don't print it. Case is served. Now we can use variables in this. Name equals Renzo. Now, what we learned, we can use the comparison operators. So, is name equal to Sean? This is the correct name. Is name equal to Sean? We're asking that. If it is, then print this is the correct name. It doesn't do anything because name is equal to Renzo. What you're saying, if the name is equal to Sean, equal to Sean, because we're using a double operator, equal symbol, this is a correct name. It will print that. But if we put Renzo, this is a correct name because behind the scenes, this will convert into true. If true, print this is the correct name. Get so far? That's how you use if statements. Now, if you want to have multiple statements, like if this is Renzo, then do this. However, if it is not Renzo and it is something, print this. If you want to have succeeding statements after the if statements, assuming that it doesn't succeed. So for example, to do that, we can use elif. If the name is Sean, this is the correct name. If the name is Renzo, oops, I accidentally executed it. Print, this is also a correct name. Now that you have two statements here, you can add as much elifs as you want. So name equals Jeff. Also correct. One thing to note also is you're not even required to put parentheses. You can also do like this one. Same thing. It still works. Banana. Maybe correct. But this is the fallback statement. Else, meaning none of the conditions succeed. This will produce anything that falls back. I mean, it's like a fallback. So like, if everything doesn't work out, then you should print none of the names work. Here, that we put Renzo. So this will print, this is also a correct name. But for example, we put Jeff. Let's put Jeff here. Also correct, because it says here, if the name is Jeff, print also correct. Now, if you put like something like banana, may be correct. But if you put like something else here, and none of these conditions are true, this is like false, this is false, this is false, this is false, then it will print the else statement, no matter what. None of the names work. None of the names work. Let's put Cardi B. None of the names work. So yeah, that's basically how if statements work. Now you know how to do if statements. Let's discuss loops. Loops. How loops work? There's something called, we call a while loop. There's something called a for loop. Let's discuss the while loop first. Now, for example, while true, let's say while true. Actually, let's not do true because our program will break. First, we want to instantiate a variable. Let's call it I. There you go. Now, while I is less than 10, for example, in this case, 0 is less than 10, so it will run. It will keep running until I is no longer less than 10. Get? So for here, we're gonna print this is the value of I plus we're gonna concatenate it. Now, if we put like I here, this isn't gonna work because you can't add strings with numbers like integers. We want to convert it to a string for it to work. Oops, we want to convert it to an int. Oh yeah, tama, string. Then, if you do this, it's gonna keep running and running. Why? Because I will always be 0. It's gonna keep putting 0 here. Okay, print this. 0 again, print it again. 0 again, print it again. It's gonna put an infinite loop, which you don't want because your program will crash. So every time, after printing, we want to add +1 to I. So I equals I plus 1. This is saying, inside I, we're gonna get the value of the current I, then add it to 1. So this will result to 1, and then it's gonna place the 1 inside the I. Now this will update to 1. Gets ba? So that's how you do it. You say this is referring to the current value, this is referring to the future value. Now, there's a shorter way to do this. You can use plus equals 1. That's just basically I plus 1, but in shortcut. There. Now, if you want to know if it works, let's run it. Oops, we forgot to place a space. And put semicolon there. There you go. Then this is the value of I. 0, 1, 2. Now, it stops at 9. Why? Because once it prints 9 here, the value of 9, it's going to print, this is the value, 9. It's going to add +1 to the current one, to the current I. So it's going to result to 10, right? Now, if we put 10 here, this is not going to work, and this will produce false. Now, this won't run anymore. So that's why it stops at 9. That's how you produce a while loop. Now, for a for loop, to make a for loop, all you have to do is, for example, a for loop is kind of different from a while loop. In what way? Because in for loops, you're iterating over the index. So for example, in this case, to create a for loop, we put for. Then you can name this anything you want, character, or number, or I, or X. It doesn't matter. You can name it anything you want. For this example, we're going to say car, referring to character. For car, then we're going to put in. Then we're going to put something. Like, for instance, in this case, we're going to put a string. Renzo. Oops, I accidentally ran it. Now, for this one, it's going to say for car inside Renzo. It's going to iterate every character. So R, E, N, Z, and O. Now, if we print car, let's comment this out for now. See, it's going to print R, E, and oops, I put Resno. Oh well. Z and O. So what for loop does, it's gonna iterate every index. Then per index, you can run code that will use that index in a certain way. So for example, print car is a letter inside Renzo, whatever. So as you can see here, you can manipulate, you can get the index, then use it any way you want. So for example, let's do numbers. For you to do numbers, let's say for num in. For you to produce like a set of numbers, you can use a thing called range. Then the first parameter is where you want to start. For example, we want to start at 0. Then we want to end at 5. Then we print num. See, it's going to print 0, 1, 2, 3, 4. And note that the second parameter, which is 5, it's non-inclusive or it's exclusive. Meaning, that's not part of the range it produces. So for example, in here, for num in range 0 to 5, what it does behind the scenes, it's going to produce this. Same thing. It's going to do this behind the scenes. And for num inside this range, it's going to print num 0, 1, 2, 3, 4. So that's what basically your range does behind the scenes. It produces a generator. It's something more advanced. So let's just say that behind the scenes, it's going to produce a range of numbers from 0 to 4. non-inclusive with 5. So, for example, if you put 0, 5 here, it's going to produce 0 to 4. Now, we want to make this more complicated. How? Let's use if statements inside for loops. For I in 0 to 11, because we want to have, let's say 1 to 10. Let's not put 0. So, range is 1 to 11. But since 11 is not inclusive of the range, this will produce 1 to 10 only. So for num in range 1, 11, if num is an even number, so how are we going to check if it's an even number? Remember, we have the modulo operator. This will check what the remainder is. So note, if you divide even numbers by 2, the remainder will always be 0. So that kind of refers or implies that we can get even numbers by modulo 2. Because no matter what even number you produce, no matter what even number you give, if you modulo 2 it, it's going to give out 0, no matter what. So, if the num modulo 2 is equal to 0, meaning the remainder is 0 when you divide it by 2, that means this is an even number. Else, print, this is an odd number. Now, okay, let's just adjust this a bit. Let's add the num string version because you don't want errors. You can't add numbers with strings. Oops, what did I do wrong? Oh, I forgot to add there. This is an odd number 1. This is an even number 2. This is an odd number 3. This is an even number 4, so on and so forth. So, with this knowledge, you can now do while loops, for loops. Let's print something cool with while loops. Let's say we want to print a 5 by 5 square. How are we going to do that? So maybe we can instantiate a square first with empty. We want to put like a 5 by 5 square here. Let's say row is equal to 0, column equal to 0. Let's put this call so it's easier to like read. So while row is less than or equal to, actually less than 5, because we start at 0. Then while column is less than 5, we're gonna add an asterisk to square. Then once that's done, we're gonna, okay, so what it does behind the scenes, for example, it's gonna print while row is less than 5. So there's 5 rows, right? So for every row, there's 5 columns. So for example here, row is 0, column is 0, sorry. If it's less than 5, add the square. And we don't want to make this loop infinitely, so we're gonna put call plus equals 1. So 0. Okay, row is still less than 5, so let's proceed to columns. 0 is less than 5. If it's less than 5, this will result to true, and this will print as asterisks here. Now, add one to column. 1. Is 1 less than 5? Okay, it works, so we add another one. It's 3, add another one. 4, add another one. Now, it starts with 0. So 0 less than 5, 1 less than 5, 2 less than 5, 3, then until 4. So it's going to produce 5 stars already. Now, if we do 5 less than 5, it's not going to work anymore. So it's going to go outside the loop. So what we want to do here is we want to add /n. And what /n does, it's going to produce a line break. So for example, in this case, it's going to go here. From here to here. Gets? So that, now that we went to another line, we want to make call 0 again. Then add 1 to row. Why? Because after we line break, we're saying that, okay, we're producing a new row. So we're making the row 1 plus equals 1. And the row back to 0 because we're back here. We don't want to like stick with 5 because it's not gonna print anything. So you guys get the process so far. So now that, for example, you print like 5 here, 5 here, 5 here, then you're at row, your row is equal to 4 already, so you print another one here. Once the row gets to 5, it will no longer work. Why? Because 5 less than 5 is false. So, if we check this is the code to produce that square. Oops, I forgot to print square. There you go, 5 by 5 square. Again, just a recap. It will first look at the rows if it's less than 0. I mean, if it's less than 5. If it is, it will print 5 columns. Then do the process. So it's gonna add a star, add another column until it reaches 5 columns already. Then, after that's done, if this is finished, add a new line, make column 0 again because we're going from the start. Then add plus equals 1 to row because we're in a new row. So this might be a bit confusing, but just keep looking at the code, see the process, and then you'll eventually understand it. Now, one thing to note also with while loops is that you can also use break and continue. For example, while true, if, for example, we have, let's comment this for now. Let's say we have x equals 10. If x let's see for, let me think, equals 10. Oops, break. Let's make this start at 0. Then x plus equals 1. Print. The loop has broken. So for here, we start at 0. While true because it's a while true, it's gonna run forever, infinitely. But you can break a while loop with a certain condition. So if x equals 10, break. And for every while loop, we're gonna add 1 to x. So in this case, oops, let's print x in between so you can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But when it's at 10, break the loop. Now, we can also use something called continue. If x is equal to 4 or x is equal to 7, continue. What this does, instead of going to the original path of the while loop to going, like, for example, it's going to execute this first, right? This, then this, then this, then this. What a continue does is, from here, if it goes to the continue, it's going to go back up. Gets? So here, we don't want it to like stay at the same number, so let's add 1 there. So if x is equal to 4, x equal to 7, add 1, then go back up. We don't want to print it. Yes? Yeah, so let's try it. See, it doesn't print 4 or 7. You might be asking, why did I put this again? Again, because if we just make it is x equals to 4 and x equal to 7 continue, the number is going to stay the same. We wanted to add plus equals 1, then go back up. Because in a continue, it's not going to run everything below it. I hope that makes sense. So, yeah, that's pretty much what you can do with while and with loops in general. Now, let's discuss functions. Yes, functions. What are functions? They're basically chunks of code you want to run multiple times in your program without having to do it manually. For example, let's define a function by using def. We're saying define. Then the name of the function is like saying what you want to name it. Let's say hello. Then let's put parentheses, then semicolon. Then we want to print hi. Now, if we say hello to run this, we just get the name of the function, then use parentheses, meaning you're going to execute the function. So if we say hello multiple times, say hello. Say hello. Now, what's going to happen? Hi, 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 hi. So instead of doing print hi, print hi, print hi, you can just keep calling a function. Now, this might sound like redundant kasi if you print hi, isn't it the same thing as say hello? But if you have something more complex, like for example, print more stuff, then you have a lot of stuff. Oops. Imagine without functions, you'd have to like print all of this one by one, 4 times. But if we do that, it's gonna do it 4 times for you. That's the power of functions. Now, instead of just printing, we can use functions to execute programs. How are we gonna do this? We can actually add parameters here. So num. You can name this anything you want. You can name this I, X, banana. But for now, let's just name it num. Now, with num, you can do anything with num to execute a program. For example, if num divided by 2 is 0, modulo na lang. If it's an even number, print it is an even number. Now, we want to insert a number here. So every time we execute a function, we want to put a number. So for example, we put 10 here, 9, 8, 7. So what, why is this red? That's weird. That's weird. Oh well, that was weird. But as I was saying, let's put 9 here, 8 here, 7 here. So in this function, we're defining a function called say hello. And here, the user can input anything they want. But here in this case, we want a number. Then what Python does, it's gonna get that number the user inputted, store that in a variable called num. The same thing that we named this. So for example, we named this num. We also get the value by using num inside the program of the function. Then modulo 2 is an even. In this case, we put 10. It's an even number. In this case, we put 9. It's not an even number. Actually, let's put it here. It is not an even number. There you go. If you put 10 in num, it's going to say it is an even number. If not, it is not an odd number. It is not an even number. It's an even number. It is not an even number. So you can see the power of functions. Like, you can run like different programs multiple times inside your program. So it's like a sub-program where what you can run multiple times without having to do this. Like, you don't want to copy paste this. Like, without functions, you'd be like num is 10, num is 9, copy paste. This is gonna be too redundant. But with the functions, you can just tell the user to input something here whenever they execute the function, and it's gonna store that in num. And if num is an even number with modulo 2 equals 0, it is an even number. Else, it is not an even number. Now, we don't want to just put print here. Why? Because we want, for example, we want to store something inside a variable, like the result of that function. How do we do that? We use return. This is an even number. Return. This is an odd number. Now, for example, I name a variable called x. Then say hello, 10. It's gonna store the result inside x. Then if we print x, this is an even number. So think of return as like a way for functions in Python to give out a value. Because if we just print it, we're just printing it for the user to see. But if we want to we want to store a certain value, we want the return value to be stored somewhere inside our program, we use return. So if we, for example, we use print instead of return, what's gonna happen? See? It's just gonna end up printing none. Why? Because it doesn't return anything. It's just printing. But in this case, if we put return, it's gonna store that value in x. So this is useful for like whenever you want to store something a function produces inside a variable, in which you can repetitively run in your program anytime you want. So that's how you use a return statement. So for example, we say yes. Let's name this is even. We put no. Then store it in here. We're storing it in x. Is even. Then we store 10. Let's say this is result. Result is even 10. If result is equal to yes, we're gonna run another function. Let's produce another function here. Print result. Yeah. We're gonna print the result is an even number. Let's just say that. Print result. See, we can also use functions inside if statements or like loops or whatever. Else, for example, let's put a parameter here. Let's say result. Actually, let's not do that anymore. Actually, yeah, let's just stick with that. So what happened here? Let's just chop it off. Now, we're calling is even, adding 10 to num. Since the value is yes, it's going to return yes. Store it inside result. So result is now yes. If result is equal to yes, print the result with another function, which is this. Print the result is an even number. Let's try it. There. The result is an even number. Then, let's put, yeah, I think that's it for functions. Basically, use a return statement if you want to store it inside a variable. Then functions are basically just repetitive code you want to keep storing inside your program. Let's talk about lists. Oh yeah, one thing I forgot to tell you guys about is the none operator. None. What none is, it refers to like, you're implying that there's nothing. So x equals none. Print x. Obviously, it will print none. So like you're saying that there's nothing in x. That's just like you're just implying that okay, there's nothing in x. That's basically what none is. Okay? Okay. Before we talk about lists, I want to actually talk about like truthy and falsy values before that. Sorry if it's getting messy. Now, truthy values. Actually, let's talk about falsy values first because it's more, you're going to understand truthy values before. You're going to understand truthy values by learning about falsy values. So falsy values are like things like 0, empty strings, empty lists. We're going to talk about lists later on. Dictionaries that are empty, so on and so forth. Also false, obviously. False is a falsy value. Truthy values are values that are not falsy. For example, if, let's put like 0, oops, print true. As you can see, it will not work because 0 is a falsy value. If we put here empty string, it's still a false value. Why? Because behind the scenes, falsy values will produce false no matter what. Empty string won't work. Now, if you put like false, obviously it won't work also. But if you put anything other than a falsy value, it will print true. If you put 5, true. Yes, true. A list with items in it. True. So, what does this imply? How can we use this properly in a Python context? I'll tell you about inputs. So for inputs, we want to say like, we want to get an input from a user. Okay, let's input first. Then, inside the input, we want to ask what we want to get. So for example, give me a name. Then, the answer to the input, which the user will give, it's going to store here. And since we want to store it inside somewhere, we're going to insert it into a variable. Now that we inserted it into a variable, we're going to say if x print the user has inputted something. You're going to be wondering, if x, that's not even a condition. How is that going to work? Well, let's check. Give me a name. Let's enter nothing. Nothing happens. If we put a name, Renzo, the user has inputted something. Let's put a space there. Try again. Another thing. Okay, let's put an else statement. Print. Please print something. Give me a name. Renzo. The user has inputted something. If we put nothing, obviously, Python will see this as an empty string. And since it's an empty string, this will evaluate to false. which means it will print the else statement. Enter nothing. Please print something. So you can see how truthy and falsy values are very useful in using conditions as well. So you can check if the user inputted something. If there's nothing, then truthy and falsy values can be incorporated as well. Okay, so now we'll be discussing more on strings. So what are strings? It's basically like a list of values you want to like chunk up together into one variable. So for example, you can put Renzo, John, Michael. Let's just name this variable students. So if in case you want to like chunk up different values together, you don't want to like put student 1 is Renzo, student 2 is John, student 3 is Michael. Instead, it would be way better to just put it combined and then store it inside a variable. But in this case, how can we make it more useful? In this case, if we want to get Renzo, you use the index. You use bracket notation to get the index. So same thing with strings. You can get this by using 0, starting with 0, so 0. Then, you can get the index of 1 also, then the index of 2. Whoops, students, not student. There you go. John, Renzo, Michael. Now, you can also get values in the negative index. How will this work? This starts with negative 1. This is negative 2, negative 3. But going to the right, it starts with 0, 1, 2. Going to the left, negative 1, negative 2, negative 3. So for example, if I get negative 1, negative 2, and negative 3, oops, there. Starting at negative 1, it's Michael, then negative 2 is John, and negative 3 is Renzo. To get the index, you can also like store it in variables. So for example, x is negative 1, y is negative 2, z is negative 3. You can also place it instead of the integers themselves. It should still work the same way. Now, how do we get, instead of just one value, we want to get more than one name. We can use slices. So for example, we also use the index using bracket notation. Now, instead of just inputting one number, you can put 2. And in between, you have the semi over there. Then, it will say here, and let's get from 0 to 2. This is similar to range. This one is non-inclusive. So this will only get the index of 0 and 1. Gets? So if we put 0 here and 2 here, we're saying get the values of the index from 0 to 1. Let's check. Oops, students. Renzo and John. What if we want to get Renzo only? We can get this 0. Renzo. So we can also like have a lot of indexes at the same time. You can get the index of a value you got by doing an index. You get me? What if we want to get, for example, we have a lot of items here. Rain. Sean. What if we want to get from Renzo to Rain? So we can count 0, 1, 2, 3. Now, the last index is non-inclusive, so we should put 4. Students, 0 to 4. This will imply get the indexes from 0 to 3. There. Renzo, John, Michael, and Rain. There you go. If you want to get everything, you can put 5 here. So 0, 1, 2, 3, 4. Then 5, non-inclusive, so 0 to 4. Renzo, John, Michael, Rain, Sean. Is there an easier way to do this? Yes, there is. we can just do from that. We can just use this. Just don't put any numbers. We're saying that it starts from the very first and ends at the very last. So what if we want to start at index 1 to the very last? You can just put 1, then ends at the very last. So John, Michael, Rain, Sean. To Michael, Rain, Sean. Now, if you want to go from the very start, then end somewhere, you can just put nothing there at the start, then put a number, an index at the end. So for example, from the very start, then end until 3, non-inclusive. So 0, 1, 2. So Renzo, John, Michael, 0, 1, 2. And that's how you get values by using index. Now, what can we do more with list? We can get the length of list using, let's comment this out. Get the length of list using length students. You see 5 because there's 5 items in the list. You can also multiply list, which is something you also see in Python and not in other languages. Students times 5. Renzo, John, Rain, Sean, Renzo, John. So it's just going to repetitively place it inside the string 5 times. What else can you do? There are also many methods you can do here. List methods. Let's search. See, there's append. We want to add an element at the end of the list. How are we going to do that? Let's comment all of this out. So, for example, students.append. Let's add a new name. Let's say Mark. Then, students. If we print students, Mark is now part. But if we add another one here, let's say Paul, it's not going to work because append only takes one argument. So what if we want to add more? We use the extend, which is here. Add the element of a list to the end of the current list. So it has to be an iterable. Iterable meaning it has to be a list, basically, or a generator. But for now, let's just say an iterable is a list. So we just extend it. We put Mark and Paul inside, and we put it inside a list. Now, if we print students, oops, it's going to say Renzo, John, Michael, Rain, Sean, Mark, and Paul is now part. What else can we do? We can do count. So for example, count. You want to count how many Rain students are there. So instead of this, we can do students.count. Let's print students.count Rain. How many Rains are there in the list? There are 2. So as you can see, methods have a lot of, lists have a lot of methods you can use. Pop removes the element at the specified position. If you want to remove an item, you can use pop. So for example, students.pop. Then the index. What do you want to remove? Let's remove Michael. 0, 1, 2. Index of 2. Then we print students. As you can see, Michael is now gone. So there's a lot of methods you can use. There's also students.sort. It's going to sort them alphabetically. John, Michael, Rain. So it's going to do it alphabetically. So it starts with John, ends with Sean. So don't be afraid to look at methods you can use in this. And yeah, that's how you can use this. What else can we discuss? Oh yeah. What if you want to check if something is in the list? So, for example, here, Renzo. How do we check if Renzo's in the list? We use the in. Students. Is Renzo in students? Let's check. True. Let's put, now if we want to negate this, if we put not, is Renzo not in students? False. So what that does is it's gonna negate the in, and if Renzo is in students, it's gonna put true. But if you put a not there, is Renzo not in students? It's false. So just you can read it in English basically. If it's not in student. What else can we discuss? So that's how lists work. You can also iterate over lists. So for example, for item in students, print the item. Renzo, John, Michael, Rain, Sean. So you can also iterate over lists. Now, for example, in list though, you can have different values. So here 10.5. So you can have a number, you can have an integer, you can have a string, you can have a boolean, you can have floats, etc., etc. So don't be afraid to like have different values as well. But more or less, like you won't really be doing that most of the time. Let's have numbers. Let's say 10, 15, 20, 35. For example, for item in num, for I in num, if num is an even number, sorry if you keep doing this, I'm just showing you how you can also use for loops and lists. Print num. For I and num, oops, if print I, sorry, there. And as you can see in the list, there's only two values that are even, so which is 10 and 20. So those are lists. Okay, hello, this is Renzo from the future. And one thing I forgot to talk to you guys about regarding lists is how you can replace them, because replacing them is a very vital part of like how you manipulate lists in general. So how do you like change a certain value in a certain index of a list? So in order to do that, you type out the name of the list, then get the index, for example 0, we want to replace the value of 10, then you just equate it to the value you wanted. You can make this 12, then you can get the value of index 1, then make this 15, wait 3015, let's name it a string, yes, or something. Then we can get the value of negative 1 index, which is 35. We can also make it a boolean if you want. Then, if we actually print num, what's gonna happen? As you can see, the list has already been replaced with values. So that's how you can manipulate lists. One thing to take in consideration though is, in comparison to strings, strings are immutable, meaning you cannot replace the items inside of a string. For example, if I have a string here, let's name it name, and equate it to John. If we get the value of j, and then we equate it to like R, so it becomes Ron or something. If we print name and execute it, it says here, string object does not support item assignment, meaning you can't change the values of strings. So that's something you should take in consideration of. Then one more thing I forgot to take note of regarding functions is that you can have more than one parameter. So for example, let's define a function here. Define sum a and b and c. Now you just want to get three numbers, then return the sum. A plus b plus c. Now, if you get values and input it to the sum function, 1, 2, 3, then print it. Let's print the return statement. You get a value of 6. So that's something you should take in consideration also. You can also have multiple parameters in functions. So yeah, back to original. So the last thing we'll talk about is dictionaries. What are dictionaries? For example, we want to have a grocery list. So we can have item 1, bread. Item 2, soap. Now, the thing with using list for like, in a way like this, it's not really like helpful because there's no order in which you can say that item 1 refers to bread, item 2 refers to soap. So that's where dictionaries come in. You can put them in key value pairs. So item 1 refers to bread. Then item 2 refers to soap. So you also use this in between to refer that item 1 refers to bread. And unlike lists, where you get the index using numbers from 0, starting from index 0, you get the index of, for example, you get the value of bread by using the key as the index. So for example, item 1, bread, item 2, soap. So that's the power of dictionaries. You can actually sort. You can sort of like have a key value pair referring wherein something refers to another thing. You get me? So like item 1 refers to bread, item 2 refers to soap. Now for example, let's make this more complicated. Let's say other items. Then let's say other items as a list. Let's say snacks, candy, chocolate. As you can see, item 1 is bread, item 2 is soap, and other items, because you got so lazy, you just place them all in a list. Now, what if we want to get candy? How are we going to do that? First, we get the index of other items. Then, we get candy. So that is in index 1. Candy. As you can see, if you do the index of other items, you get the list itself. But if you do index 1, you get candy. So that's how dictionaries work. You can also look through dictionaries for I in x.keys, print I. So it's going to iterate over the keys. But if you want to iterate over the values, I. See, it's going to print bread, soap, and snacks, candy, and chocolate list. So this is really helpful for like having key value pairs in Python. I think that pretty much sums up how dictionaries work. You can just search dictionary methods in websites. Python dictionary methods. Clear removes all, removes the element with the specified key. So for example, if we use pop, x, comment this, x.pop, item 1. Then we print x again. Item 1 is now gone. What else can we use? Let's use update. How do we use update? Let's check it out. Yeah. So we insert a dictionary inside. So let's say, let's comment this. X.update. Let's put item 3. Then, let's say item 3 is me, because I'm a snack. Wink. Now, as you can see, item 3, oh, I'll move my camera now. Item 3 is now inside the dictionary. Item 3, me, because I'm a snack. Yes. So, pretty much, the methods are now online. You can just check, don't be afraid. How about items? Let's say items. You can also iterate and then get the key and the values at the same time. For I in x.items, let's say for key and value in x.items, print f string. This is the key. Then we put the value. This is the item 1, bread. This is the item 2. So this is the other item, snack, candy, and chocolates. One last thing I want to talk about are list comprehensions. This is not required, but it's a good to know. So in list, you can also do list comprehension. So for example, x for x in range 0 through 10. What does this mean? For x in range 0 to 10, put x inside this list. That's basically a shorthand to print to have a list of values from 0 to 9 because 10 is non-inclusive. So if we print x, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Shortcut. Let's say cars. Car for car in Renzo. It's gonna print a list with the letters of Renzo. R-E-N-Z-O. What else can we do? Let's say, let's name this nums. Let's say num for num in range 0 to 10. If num is even. Oh, we forgot to print it. See? We can also put conditions in list comprehension. So for num in range 0 to 10, print num. Actually, for num in range 0 to 10, if num is an even number, put num inside. There you go. So it's a good to know. If you know list comprehensions, it kind of makes your code a bit cleaner. It looks better, but you're not required. You can also do this in a short way. Actually, I won't do it anymore. Just to let you know that list comprehensions also exist. So that's pretty much it. You learned how. Let's take a look back. Math. You know how math operators work. Data types. What are data types? There's integers, floats, strings, booleans. And since we already discussed it, list dictionaries are also data types. There's also strings. So we understood how to print strings, store variables. You learned about string methods like capitalize, upper, lower, the length, and getting the index. We learned about flow control, so equals equals. Those are like comparison operators, less than equals, greater than. You also learned about Boolean operators using and or. Then we talked about if statements like name equals Cardi B, if blah 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 blah, print this. Elif, that's a secondary statement. Suppose that if doesn't work. It's gonna go line by line, and if there's a fall, if none of them like are valid, it's gonna fall back to an else, which this will execute. We also talked about loops, while loop, and for loop. So for example, while loop, we have you start with 0, while I is less than 10, print, and then iterate I by 1. For loop, it's gonna go through each index. So where's the for loop? Here. For num in range 1 to 11, if it's even, if it's modulo 2 equal to 0, then this is an even number. So for loops go through each index, while while loops execute while a certain condition is met. We also learned about functions, how we can use them to write chunks of code we want to execute properly. We learned about the return statement. We learned about truthy and falsy values. If it's a falsy value, it's more or less 0, empty strings, list. If you put that as a condition, then it will execute as false automatically. Otherwise, it's true. So this is useful for when you get an input from a user. Yeah. Then we also talked about lists, how we can use lists to like store chunks of values. We learned about their methods like extend, sort, append, and how we can also iterate over lists. And we also learned about list comprehensions. Then we also talked about dictionaries, how we can have key value pairs where a certain key refers to a certain value. For example, item 1 refers to bread, item 2 refers to soap. Then we can also have many methods like pop, update, .keys, .values, .items. So thank you guys for attending this Python workshop. Let me know if you want to have a part 2. We're going to talk about object-oriented programming. But otherwise, that's pretty much it. So thank you guys for watching. Let me know if you guys have any questions. Just message me or the MISA help desk, the e-services help desk. I mean, or feel free to just comment in down below on your comments and suggestions and questions regarding what I discussed so far. So thank you.